Okay, good evening. This is Professor David J. De Los Reyes. Okay, our topic for tonight will be, I think, this will now be the last topic on advanced mathematics. Okay, this is Maclaurin's series of expansion. Maclaurin's series of expansion is actually the method and how we find the relation of any function in terms of x. Okay, let's proceed. I will check my camera. So we are now on advanced mathematics, lesson number 39. The title of the subject matter for tonight will be Maclaurin's series of expansion. Maclaurin's is actually the family name of a mathematician that derive this formula. And the formula for Maclaurin's series of expansion, okay, it's a little bit long, okay, but we could simplify this one later on in the actual problem. For Maclaurin's series of expansion, the formula will be something like this. Function of x can be written as, we got the right hand side, f of 0 plus f prime of 0 multiplied by x. This is multiplied by x. Okay. The next term will be f double prime of 0 all over 2 factorial. This is multiplied by x squared. That's the second one. Plus f triple prime of 0. If this is 3, this should be 3 factorial. All over 3 factorial times x cubed. Okay, that's the fourth one. Plus, okay, there should be many things, but this is plus, plus. Okay, the second to the last will be f of n minus 1 of 0 all over n minus 1 factorial. If what is the exponent, the factorial at the bottom will be the equivalent of that one. You just put factorial, that is the quantity n minus 1 factorial. Like this one here, this is 2, so this is 2 factorial. This is 3, so this is 3 factorial. So if this is n minus 1, the bottom portion, the denominator will be n minus 1 quantity factorial. This is multiplied by, hold on, this is something is missing here, times x raised to n minus 1. Okay? If this is second, this should be second. If this is n minus 1, this should be n minus 1. That's the second to the last. Plus, the last part will be function to the n of 0 all over n factorial times x to the n. Okay? That's Maclaurin's series of expansion. So actually, this is a very long formula. We just simplify it. We write the first 4, okay? Then plus dot, the second to the last, and this should be the last part. The last part will be with the power n. This is n factorial, x to the n. The second to the last is actually f raised to n minus 1. So this is n minus 1 factorial. The power of x will be n minus 1. But later on, if I will give you a problem, I will try to say that up to the f triple prime or f to the fourth derivative, we could stop already, because when we will compute the other values, the significance on the actual solution is actually minimal. So actually, we'll just use up to fourth derivative or fifth derivative maybe. That's very, for practical purposes. We will not include all the things, okay? Maybe up to fourth derivative or fifth derivative that will be found already for the value of a function of x. Okay, I will place a note over here. 2 factorial is actually 2 times 1, or that is actually 2. 3 factorial is actually 3 times 2 times 1, this is 6. And 4 factorial is actually 4 times 3 times 2 times 1, this is 24. So as you notice it, as the number increases over here, this is actually increasing. Right? So if this is increasing, okay, the last remaining terms will be very minimal in the effect on the final solution. So I have told a while ago, maybe up to fourth derivative or fifth derivative, that will be fine already. Okay, so this is actually Maclaurin series of expansion. Okay, I will repeat it before I will give you an illustration on how we will use this Maclaurin series of expansion. Again, I will check my camera. Function of x will be f of 0, f prime of 0 times x, f double prime over 2 factorial of 0 times x squared. So as you notice it, this is x squared, x cubed, it is increasing, right? The third one will be f triple prime over 3 factorial x cubed. Second to the last will be f raised to n minus 1 over n minus 1 factorial. This is x raised to n minus 1. The last one will be f raised to n of 0 over n factorial times x to the n. Okay, I will try to bring out an illustration so that we could visualize the importance of Maclaurin series of expansion. Maclaurin series of expansion is actually where we got the equivalent of any function. Okay? Of any function. Okay, I will give you an example. Obtain Maclaurin's expansion of cosine of x. Or meaning, we will derive cosine of x as a function of Maclaurin series of expansion. There should be a formula on how we could compute for cosine of x for this given problem. Actually, any function that we would like. Sine, cosine, tangent, or anything. We could use Maclaurin series of expansion. Okay? Okay, let's try to bring out the solution. Function of x will be cosine of x. The given equation, right? Function of x. F prime of x, meaning the first derivative of the function. The derivative of cosine is minus sine, so f prime of x will be minus sine of x. We will take the second derivative. The second derivative will be the derivative of the first derivative. So this is, this was erased, right? The derivative of negative sine x. It will be negative open quantity. The derivative of sine is actually cosine. Okay, the sign of cosine inside is actually plus. So a plus and a minus, this is still a minus, right? The third derivative will be the derivative of the second derivative. Okay, f prime of x will be negative. We'll bring out the negative sign, open quantity. The derivative of cosine is negative sign of x. So this is a minus, okay, and a minus. This will now be plus sine of x. Meaning the third derivative of x will be plus sine of x. Okay? That's differential calculus. Differential calculus is a part of advanced mathematics. It's a part of the solution. Let's try to take the fourth derivative. The fourth derivative of x will be the derivative of the third derivative, right? So this should be equal to, this is plus, right? So there's no problem. And the derivative of sine will be plus cosine, so this is multiplied by cosine of x. It is plus. So a plus and a plus will still be plus cosine of x. Okay? The sign positive and negative is actually very important in the solution. Okay, I will repeat it. F of x will be cosine of x, f prime of x will be negative sine of x, f double prime of x will be the negative cosine of x, negative. triple derivative will be positive sine of x. Okay? We derive it, a minus in minus, that will be plus. Fourth derivative will be plus cosine of x. These signs here, plus and minus, are actually very important because when we substitute on the formula, if we made a mistake on the sign, we are gone. Right? Okay, let's try to proceed. F of x will be cosine of x. What is f of 0? F of 0 will be cosine of 0. Cosine of 0 degree. This is a special one. Cosine of 0, if you are an electrical engineer or a mathematician, it is 1. Cosine of 0. 0, take the cosine, is 1. So f of 0, meaning cosine of 0 will be 1. We needed this value when we go back to the Maclaurin series of expansion. Okay? What is f prime of x? F prime of x is actually negative sine of x. So f prime of 0 will be, there should be a negative sign over here. Negative, open quantity, sine of 0. 0 is a special number. Cosine of 0 is 1, sine of 0 is actually 0. We put 0 here. Okay, we press sine. The sine of 0 degree or radian is actually 0. So this is 0. Okay. Second derivative, f prime of 0. So this should be negative open quantity. Cosine of 0. But cosine of 0 is 1, right? So this is equal to minus open quantity plus 1. A minus in a plus, this is minus 1. Right? The third derivative, f prime of 0. We're following this, right? Should be equal to, it should be plus sine of x, right? Hold on. There should be a plus over here. This is plus. Plus open quantity sine of 0. So this should be equal to plus. I'm putting the sign because it is important. Because just in case the sign of the term inside is a negative, there will be an effect. Plus open quantity. Sine of 0 is actually 0. Okay? 0. A plus and a plus will still be a 0. Okay? The fourth value, the fourth derivative, f to the fourth of 0 will be, it should be plus cosine of 0. And this is 1. So f to the fourth of 0 will be 1. So we needed these values here. 1, 0, minus 1, 0, and 1. If we made mistakes on the sign, we are gone. So just be careful with the sign. So if we try to go back on the Maclaurin series of expansion, you don't, what you call this, question it, guys. Why I just stop at the fourth derivative? As I told you a while ago, up to fourth derivative or fifth derivative, the significant figure will have an effect on the solution. But beyond that, the effect of the terms, the last remaining terms will be minute. So actually, up to fourth derivative or fifth derivative, the solution will be fine. Okay? So if we try to follow this, function of x will be cosine of x should be equal to f of 0 is actually 1. Okay? F prime of 0 is actually 0. So this is 0 times x. I'm following this. Okay? F double prime of 0 is actually negative 1. So this is negative 1 over 2 factorial times x squared. Plus f triple prime of 0 is actually 0. So this is 0 over 3 factorial. We are here. Times x cubed. Okay, the fourth one will be f to the fourth of 0 is actually 1. So this is 1. So this is 3 factorial. What comes next will be 4 factorial. And if this is 4, this should be x to the fourth plus some minimal values. These are minimal values already, minimal effect, minimal values. If you go f to the fifth, f to the sixth, and you include it in the solution, the effect will be minimal. That's why I place it here, plus some minimal values. So if we stop up to x to the fourth, that will be fine. Simplifying this one, cosine of x now will be 0 times x is actually 0. So this is 0. Okay? 0 over 3 factorial. 3 factorial is actually 6. 0, 0 over 6 is actually 0. And 0 times x cubed will be 0. So this will be 0. So if we try to simplify this one, cosine of x now will be 1. I'm following this. This is 0. I didn't include it anymore. Plus minus 1 over 2 factorial or negative 1 half times x squared. This is not 0, right? Plus 0, okay, I didn't write it, plus 1 over 4 factorial. 4 factorial is actually 24. So this is 1 over 24, x to the 4, plus that, minimal values. So meaning, if we try to compute for the cosine of any given angle, the formula should be cosine of x will be equal to 1 minus 1 half of x times x squared plus 1 over 24 times x to the 4 plus the minimal values, which has a minimal effect on the value of cosine of x. So this is actually the general formula on how to take the value of any cosine function, whether in degrees or radians. Okay? This is the general formula on how to take any cosine function. We might have been gone to this world, but this formula will not change. So memorize this by heart. That is, cosine of x will be equal to 1 minus 1 half of x squared plus 1 over 24 x to the 4 plus the minimal values over here. And it will give you the approximate value of a cosine of that angle. Okay, let's try to bring out an example problem. Supposing x is actually 30 degrees. Okay, and the problem is asking for what will be cosine of 30 degrees. So 30 degrees, we put x to be equal to 30 degrees. Okay, and this formula here, x should be in radians. Okay, the value of the x should be with the unit radians. Okay, so if the given angle is in degrees, before you place it on the maclaurin's equivalent, it should be in radians. So I place it here, x is equal to 30 degrees, or this is actually pi over 6 radians, because 2 pi is actually 360, right? And pi is actually, we divide this. Pi radians is actually 180. 180, right? So if we divide this by 6 and divide this by 6, 180 over 6 is actually 30 degrees, right? So meaning 30 degrees is pi over 6 radians. Okay? We must have to convert first this 30 degrees to radians before we place it on the formula that was derived by using Maclaurin's series of expansion. Therefore, cosine of 30 degrees now, if we try to follow that, it will be 1 minus 1 half. What is the value of x in terms of radians? It is pi over 6 quantity squared. Okay? Plus 1 over 24 times the quantity pi over 6 raised to the 4th power plus some other values which is minimal. Okay? Very minute values already. So if we if we stop up to x to the 4th, that will be pi. Okay? So computing this one now, this will be 1 half times pi over 6 quantity squared. If we try to use our calculator over here, it should be something like this. You display pi, you divide that by 6, okay, you know the ratio. but this should be raised to the second power. So y to the x second power equals 1/2 is 0.5 times 0.5. And the value is 0.13707. 0.13707. Okay? And for the second one, this portion here, it's the same. You display pi divided by 6 equals, we got the ratio already over here, but this should be raised to the fourth power. So y to the x to the fourth power equals, okay, this is 1/24. Because 1/24 is actually this part here. 24, the fourth factorial. Divided by 24. So you see it, we divide it by 24. So actually this portion is really minimal already, but it still has an effect on the solution. Maybe the next parts will be minimal, okay? Equals. The value is 0.003131722. 0.00313. Okay? So if we try to add 1 plus this, it will be 1.0031317 minus 0.13707. And if we try to subtract this one, approximately the value of cosine of 30 degrees is 0.866. Okay? And by using our calculator, okay, to verify the validity of this answer here, we know that cosine of 30 degrees is 0.866. That is actually square root of 3/2. Okay? You just display 30 here, the unit of the angle will be degrees, and you just press cosine. And the value of cosine is 0.866 up to the third decimal. Right? It is 0.866. That's it. Actually, 30 degrees is a special number, right? Okay? If this is 30 degrees, we know that sine of 30 is 1/2, right? That's trigonometry. Hypotenuse will be 2, opposite side will be 1, adjacent side will be 2 square is 4 minus 1 is 3. So they should be square root of 3. So if we take the cosine of 30 degrees, the cosine of 30 will be the adjacent over the hypotenuse. It is actually square root of 3/2. Or this should be 1.732/2. Or that is actually 0.866. That is. Okay? That's it, guys. That's the importance of the so-called Maclaurin series of expansion. There will be an equivalent formula on how to take the value of cosine of x, but x should be in terms of radians. So if the given angle is in degree, before you place it on the formula, you change it to radians by using, you know that 30 degrees is pi over 6 radians, because pi is actually 180 degrees, or 2 pi, one complete revolution is 360, or take half of that, pi will be 180. So if you divide both sides of the equation, pi over 6 should be 180/6. And 180/6 is actually our given angle, right? So meaning, 30 degrees is pi over 6 radians. This is the value we need to place on the derived Maclaurin series of expansion. Okay, that's it, guys. So for those of you who are taking up advanced mathematics, okay, this is for you guys. If you want to subscribe to my channel is at youtube.com/@proofdavidj.de. And if you want to share it, please click share. My fourth, long form video subject matter is almost finished. Okay? So if you want to learn something, just watch my long form videos. I've got differential calculus, okay? Integral calculus, differential equation, and this is advanced mathematics. Okay? Good evening from Los Angeles.